This is our senior design report. Our topic is about a UAV tracking system, and I'm Cao Yang.
I'm Zhang Jinxian.
I'm Lu Qi.
I'm Zhang Xiao.
And our advisor is Professor Wei Wei. In an information age, many people choose to install surveillance cameras in their house, which can ensure their own personal safety and property safety. And the government also installs surveillance cameras in the street. If the surveillance cameras can really keep watch out everything of the street? The answer is no, because of surveillance cameras are installed in a fixed place and the surveillance cameras cannot rotate. So it results in blind spots which imperil people's safety seriously. So our team come up with a good idea to eliminate this disadvantage of the traditional monitoring system, which is UAV tracking system. UAV and the computer version are now two of the most popular technologies. We want to combine them to create a core application named the tracking system. The UAV powered by computer version algorithms will be able to identify a specific person from a complex background and track its target. With the UAV tracking system, people will no longer worry about the dangers from blind spots of the traditional surveillance cameras. This is the traditional surveillance system's disadvantages. It has a blind spot and it can only send little information, and it cannot track target with only one perspective. Here is our UAV tracking systems. It can have more information and track target report very quickly. We can even give introductions to the UAV, and it will track target and give feedback to our personal computer. So next is the design process. We can see from the table. Now we have completed the basic application test. Next, my teammate Lu Qi will introduce the project requirement and assessment metrics.
We divide our project into 6 parts. Then I will introduce these 6 parts. The first one is hardware requirement. Our project uses Parrot AR Drive 2.0. Why we choose this device? Because it is easy for us to write the program and it can connect PC with Wi-Fi. For the assignment, the Parrot AR Drive 2.0 can work well, and the connection of PC with Wi-Fi will be stable. The second is software requirement and assessment. For the requirement, this project is based on the robotic operating system. It's also called ROS. For the programming, we wrote code in Node.js, a new language for us, I think. For the assessment, the code will be work as our designed. Third is recognition. For the requirement, we plan to achieve the recognize of the target and then the recognition of the target's movement. We will use OpenCV database to achieve the recognize of the target. For the assessment, 90% is our goal for recognizing the target. If we finish that goal, then we will still work for 95 to 99%. The first one is checking requirement. After recognizing the target movement, the PC will do some adjustment according to the movement data sent by UAV, and then the PC will send the adjustment to UAV. For the assessment, PC can successfully get the information from UAV, while UAV can get the adjustment from PC and do the response. The fifth one is reliability. For the reliability requirement, we will test many times, at least 100 times, to make sure the reliability. As for the assessment test, we will test in different environment and reset the settings before test. As for report, the requirement of report, GPS device is needed in this part. Therefore, we can record the flight paths and send to the user timely. Assessment. User can receive the moving check timely. And then my teammate Zhang Jinxian will introduce the issues of concern.
Okay, now I want to talk about the issue concerned we will meet in the future design. And those issues may happen in recognized part and track part. Issue of concern is about recognize. In this part, we may meet three issues of concern we will inhibit the success of our project. The first one is programming about the recognize. As we can see in the PowerPoint, the first one, our project is recognize the back view of the target based on ROS, and it might be a little bit difficult for us to achieve. And the second issue of concern we might meet in recognize the side view of the target because our UAV recognized is based on recognizing the back view of the target. When the issue of concern is recognized of the target when the target quickly. When the target suddenly turn left or turn right, it is a challenge for our UAV to recognize the target. The third issue of concern is recognize the target when the target quickly change his back view. For example, we imagine the situation where our target quickly take off his coat, then the change of his back view will increase the difficulty of our UAV recognize. And another issue of concern is about track. We consider the condition where our target hide behind a tree and our UAV would lost the target. Then how to catch our target again is the issue of the concern which might inhibit the success of our project. So there are all issues of concern we consider about currently. Then I will introduce the status of our project. As we can see in this PowerPoint, this semester, we finished the first and the second step of our plans. We select Parrot AR Drone 2.0 of our UAV in our senior design, and we successfully achieved the basic flight programming in our computer and controlled our UAV flight by those programming. Those are the prototype of our project. And after our coding program, the 90% of project will be finished, and then we will be ready for our project demonstration at TechExpo in March. And finally, this is a video we controlling our UAV by our computer. And the next, our team member Zhang Xiao will introduce the design overview.
Okay, At first, the Parrot AR drone can only be controlled by an official iOS application provided by the company. We then play around with the SDK and protocol provided by the company. After hard working, we can now write program in Node.js running environment and send our program to the drone through Wi-Fi. That's to say, we can now build our own application from scratch. You can see from the video that the drone first take off, stay a fixed distance away from the ground, rotate a specific angle controlled by program, move forward a fixed distance, and finally land on the ground. The movement itself seems really simple, right? But in fact, any complicated movement can be divided into the 5 operations in our project. And in order to make our following project easier, we now package the programs separately, and we can call them in our following applications like recognition and tracking. So this is what we done in the video. Next, since we have already made it clear how to control the UAV with Node.js commands through computer instead of using the controller given by Parrot AR drone controller, we will move to the stage introducing RS, the robot operating system, to our project. And in fact, it's not very fair to call RS a robot operating system because actually it's not a real operating system. It's just something like a framework. And RS is a platform used to develop robot applications. It provides an integrated development environment, so we can employ RS to help complete our UAV movement control, target recognition, and tracking. Everything will be very easy with RS. And for the target recognition and tracking tasks, the key point is the image processing based on machine learning. And recently, deep learning is well used, so we may use deep learning. And since it's hard to complete the algorithm all by ourselves, we're going to use OpenCV directly and combine it with a movement control to build our 3 main functions, including recognition, tracking, and for example, tracking a person behind tree or something like that. Next, I will introduce something what we are now working on. Since we already make it clear how to control the drone by our computer and write program in Node.js, we are now starting RS and try to introduce it into our project. However, we found a very important problem that OpenCV doesn't provide a RS version. Like what we said previously, RS is not a real operating system, so it's not out of our exception that OpenCV does not have a RS version. What we are working now is to complete a transform mechanism, which means we are going to change image type from sensor MSJS to CVMAT. You know that the kernel point to do the recognition and tracking is to process image get from the camera on the drone, right? The image type we get directly is RS image message, and we will build a CV bridge. It's a module in the RS system and transform the type, the sensor MSJS to CVMAT. So we can use OpenCV to deal with CVMAT documents. This is what we are working on now. And finally, we have some plan for our next semester. Yes, in the next semester, we are first going to complete our movement controlling algorithm in RS. Then we will still OpenCV in RS and process image with the help of it. At this stage, we will make make everything clear, and we will recognize our target and combine the recognition and movement control and achieve the tracking function. Finally, we will add some extra features. For example, our drone can still recognize the target even if the target change his clothing or hide behind a tree. This is our work plan, and this is our presentation. Thank you.
Thank you.
Thank you.